Hi, dear students. In the previous class, we had discussion over the preparation of manufacturing method of nitric acid. It is a part of your 15 group elements, the nitrogen. Then, what are the properties of that nitric acid? Let us discuss about the properties of nitric acid. So, it is a part of 15 or group 15 elements. Here the nitric acid is a compound of nitrogen. We discussed about the compounds of nitrogen or dinitrogen. Let me discuss about the properties of the nitric acid. Okay, it is another compound, nitric acid, is represented as HNO3. The manufacture of nitric acid, the part were discussed in the previous class. It is prepared using oxidation of ammonia. In the first step, oxidation of ammonia that produce nitric oxide, that nitrogen monoxide, and again oxidation that leads to formation of nitrogen dioxide, and followed by hydrolysis we get the nitric acid, correct? Okay. Then what are the properties of nitric acid? When you observe the physical properties of nitric acid, it's a colorless liquid, and the specific gravity is also a little bit higher, but lesser than the sulfuric acid. Okay, denser than sulfuric acid. It's a colorless liquid, and the very important property of nitric acid is oxidation property. Okay, oxidation property. It is a good oxidizing agent. Good oxidizing agent. It has a capacity to oxidize many metals into different nitrides, and itself it undergo oxidation forms a different types of oxides. The formation of oxides from nitric acid is completely depend upon the concentration of nitric acid. Let us discuss about a few examples. In that cases, we can learn different types, formation of different types of oxide from the nitrogen. Okay, and consider two important metal. These two are very important for your exam point of view also. One is copper, another one is zinc. How copper react with nitric acid, how zinc metal react with nitric acid. The formation of the product is completely depend upon the concentration of nitric acid that we have taken during the reaction. Okay, and consider copper first, reaction with metal. Reaction with metals. First, copper. Okay, here copper metal react with nitric acid. What are the possible products? Yes, copper nitrate is formed, copper nitrate is produced. This is the general thing we know. When nitric acid or nitrate compounds is react with a metal, it gives a corresponding metal nitrate. But how it react and what are the possible byproducts in these cases? That part is completely depend upon the concentration of nitric acid we taken during the reaction. If I consider the dilute nitric acid, then excess of nitric acid is required. The 8 quantity of nitric acid react with the 4 quantity of copper and 3 copper and 3 molecules of copper nitrate, and byproduct is one is water. The Production of water is completely dependent upon the hydrogen we taken. How much quantity of hydrogen taken here? 8 atoms of hydrogen is there. Therefore, 4 water molecule, exactly half of the nitric acid. Okay, exactly half of the molecules of the water is produced during this reaction. And then what is the other product formation during this reaction? Nitrogen 2 into 3 6, 2 nitrogen monoxide. Nitrogen monoxide is produced. Okay, so this is the very important thing. Very important thing. Okay, when what is the conclusion? When concentrated nitric acid react with the copper, it produces nitrogen monoxide. So it is dilute, in a dilute condition. What happened when zinc is react with dilute HNO3? Same. Okay, dilute nitric acid. So here, according to the oxidation property of the copper and zinc, or what we studied in the first year, or the equilibrium topic of the first year, or the redox reaction and all that. So in that cases, okay, we saw one thing, the electrochemical series. Okay, the potential of the oxidation property of the copper and zinc, depending upon that, the copper is react differently with dilute nitric acid, zinc is react with HNO3 in different way and produce, one is fixed, then corresponding metal nitrate. Here I am using zinc nitrate is produced, and it is because of the dilute nature of the nitric acid, it produces nitrous oxide, nothing but laughing gas. Okay, nitrous oxide or N2O. This oxide is produced during this reaction. Okay, and water. Balancing this reaction, 4 molecules of zinc react with dilute nitric acid, produce 4 molecules of zinc nitrate, and here 10 molecules of nitric acid produce 5 molecules of water and nitrous oxide. Okay, this is the another case of reaction of dilute nitric acid with metal. Okay, one case copper, another case zinc. These two reactions are very important for your exam point of view. Okay, you should remember all these two things, and not only these two things. Next, how same metals react with concentrated nitric acid. Okay, let us discuss it. First one, copper. When copper is react with nitric acid, it is concentrated now. When concentrated nitric acid react with copper, again similarly copper nitrate is produced, is a one product, and it produces nitrogen dioxide and water. Just observe the reaction. This possibility of formation of the different types of oxide is completely dependent upon the concentration of nitric acid, and in the nitric acid, nitrogen shows variable oxidation state. Nitrogen has different stable oxidation state. Because of that, different types of oxides form with metals. Okay, here how much quantity of nitric acid is required to balancing this reaction? Okay, here 2 nitrogen, correct? 2 nitrogen, so 1 plus 2 plus 1, 3 HNO3, copper, okay. Now it not balanced because of the hydrogen, so therefore I am taking its 4. Suppose I am taking is 4, then 2 molecules of water is fixed. Okay, therefore, mainly in all these cases, we take the even numbers to balance in the reaction. Okay, balance the water produced in the reaction. Now, how much quantity of nitrogen? 2, no, sorry, 4, 2, make it into 2. Okay, reaction is balanced. Similarly, zinc is react. Okay, when zinc is react with nitric acid, HNO3, and produce zinc nitrate and 2 molecules of NO2 plus 2 particle. Here, the question arises in different way because of the production of different types of oxides. Okay, there is a possibility of asking the questions which oxides of nitrogen is produced when dilute nitric acid is react with zinc, dilute nitric acid react with the copper, concentrated nitric acid is react with zinc and coppers. Okay, please remember, whenever we use concentrated nitric acid, then always it produces nitrogen dioxides, and dilute nitric acid react with the zinc produce nitrous oxide, nitrogen laughing gas. Next, dilute nitric acid react with the copper, it produce nitrogen monoxide. Okay, so these are the very important things in the oxidation with the metals or reaction with the metals. Nitric acid not only react with the metal, it has the ability to react with the non-metals also. Whenever the nitric acid react with the non-metal, again it shows the oxidizing property when the iodides, any iodide compounds is non-metal, correct? So iodine belongs to a big block element. So it is extremely right side of your periodic table. The iodine is react with nitric acid in different quantity of concentrated HNO3. Okay, nitric acid, it produces corresponding oxide acids of iodide, iodic acid. Similarly, carbon react with nitric acid, produce carbon dioxide. Oxidation take place. Oxidation of iodine, oxidation of to carbon dioxide. Similarly, phosphorus react with concentrated nitric acid in different quantity. Okay, react and produce H3PO3, and when sulfur is react with sulfur exists in different state. Correct? Sulfur exists in different state. That part we will discuss in the next part of the block elements. S2, S6, S8. S6 and S8 are the solid state and S2 is the gaseous state. Here solid sulfur react with nitric acid and produce H2SO4 or convert into H2SO4. In all the cases, nitrogen dioxide is the common gas liberated. Okay, so now the cases, because we consider concentrated nitric acid. Because of the concentrated nitric acid, now the cases nitrogen dioxide is produced. Therefore, that part become now easy. Correct. So, in whenever the concentrated nitric acid react with any metals or non-metal, generally that produces nitrogen dioxides. Okay, NO2, and the production of different oxide is completely depend upon the it is taken place when we consider the dilute nitric acid in the reaction. Okay, so these are the very important concept of properties of nitric acid. Okay, let us discuss about the very important another concept. It is the test for nitrate. During the test for nitrate, it's a familiar thing because you are well known about the test of chloride, bromide, nitrate and all that. So nitrate, during the test of nitrate, we come across one confirmatory test, that is brown ring test. So it's a familiar. Based on that part, the many questions asked in your exam. Okay, in a different way. Let us understand the concept involving in the brown ring test. Okay, so what is brown ring test and how it is conducted and all that? It is for nitrate, NO3 minus. Okay, nothing but nitrate. During the test of nitrate salt, Few example of nitrate salt: barium nitrate, strontium nitrate, potassium nitrate, ammonium nitrate, sodium nitrate. So there are several nitrate salts are there. During the test of nitrate, suppose nitrate is present, then we going through the conformity test. During the conformity test, we conduct one important test, that is a brown ring test. So for conformity test of nitrate, we conduct a brown ring test. What happened in brown ring test? So the small quantity of nitrate salt is taken, NO3 minus. Okay, it may be potassium nitrate, it may be a strontium nitrate, or it may be a barium nitrate. When nitrate salt is made to react with acid and represent acid in the form of H plus. Okay, H plus indicates acid, and small quantity of Fe2 plus. Why we should study about this concept? The reason or the need of the study of this concept is, here the one property we studied, that is nitrate or nitrogen or the nitric acid, okay, or any nitrate has capacity to oxidize the iron Fe2 plus. It has capacity to oxidize the Fe2 plus. When Fe2 plus is oxidized, then what is the oxidized product? Fe3 plus. Fe3 plus is produced. That is the oxidizer product. Okay. Here what happened? When NO3 is react with Fe2 plus, it oxidizes the Fe2 plus into Fe3 plus, and itself undergo reduction, act as an oxidizing agent, and it produce or gives nitrogen monoxide, and water is produced. Here two molecules of water, and that's 4 and consider 4 to make it even, and consider 2 into 4. So okay, 2 oxygen plus 3 oxygen is there, and nitrogen 1 nitrogen, and that's it. Now reaction is balanced, but electronic balance is not happening or not take place. In this case, to make the number of electron balance, we should multiply 3. Why? 3 electron get lost and it become plus 3. Here the electron goes to formation of a nitrogen monoxide and water. 3 losses, 3 electron gaining. That's why I am writing 3 or multiply 3. Now this is the initial condition. What are the things we consider during the brown ring test? We consider nitrate salt and ferrous sulfate, freshly prepared ferrous sulfate, ferrous because of plus 2, ferrous sulfate should be freshly prepared, otherwise there is a possibility of oxidation of Fe2 plus using atmospheric air. That's why we should prepare during the test. Therefore it is a freshly prepared. Next, acids. Commonly we consider concentrated nitric sulfuric acid for this case. First, the nitrate salt is converted into or make it into solution, that is called salt solution. In the salt solution, small quantity of water is there. Because of that, there is another possible complex, or there is a possibility of formation of another complex. The one is Fe, what we consider in the reaction, plus water, freshly prepared ferrous sulfate. How to prepare the ferrous sulfate? Solid ferrous sulfate is dissolved in water. During that cases, there is a possibility of formation of one complex, that is FeH2O 6 times. Okay. One complex is produced. It is hexa aqua iron 2 plus or 2. Okay. hexa aqua iron 2 plus. What is the reason of formation of, or what is the reason of showing plus 2? It is in the ionic form. Suppose it is in the compound form, then it is FeSO4, freshly prepared ferrous sulfate, SO4. If we consider ferrous sulfate, then it produces sulfate complex. Okay, I am simply represented in the ionic form. Next, this complex is already formed or it is added during the reaction, and in the ferrous sulfate, small quantity of ferrous sulfate that undergo oxidation with nitrate that present in the salt, that oxidized to nitrate is reduced to NO. The formed NO, nitrogen monoxide, and this complex, these two react together and forms a beautiful brown color complex that look like a brown ring at the junction of the two solutions, one complex and another solution. So that's why we call it as a brown ring. So what happened in the brown ring test or brown ring formation? Fe H2O 6 times 2 plus, here iron oxidation state is plus 2. Please remember, iron oxidation is plus 2 when it reacts with nitrogen monoxide that or nitric oxide that formed in the first step and produce in a small quantity of acidic media, it produces Fe H2O 5 times NO. So this is the brown complex. One molecule of water goes out, and this is the brown color complex. So this is the brown ring test. Okay, so this brown colored complex formed at the junction of these two solutions. Then what is the name of this compound? What is the name of this complex? You are well known about the coordination compounds and all that, and naming the coordination compound. According to the naming of the coordination compounds, the name of this compound is how many water? 5. Okay, penta, water, aqua, penta aqua, NO, nitro, sign. Here there is two possibility. Okay, one is nitrogen monoxide present in higher oxidation state, and another case present in a lower oxidation state. The difference in the lower oxidation state and the higher oxidation state is due to the transfer of electron. When nitrogen monoxide gives electron, it shows one type, and when it takes the electron, it shows another type. When it takes the electron, it is nitrosyl. When it gives the electron, it becomes positive, nitrosonium. Okay, so I am using this one, nitrosyl. When we use the nitrosyl, then nitrogen takes the electron. Now iron oxidation state is +1. Okay, that is the important thing. Okay, just once again I recall the concept. Okay, after completion of the naming, penta aqua nitrosyl, penta aqua nitrosyl. Here iron. What is the oxidation state of iron now? It shows +1. Why it shows +1? Losses electron, gives electron, and 5 is neutral. +1 goes out, +1 remain. Iron oxidation state is here +1. Penta aqua nitrosyl iron 1. Suppose it is sulfate, iron 1 sulfate. Okay. When it becomes nitrosonium or nitroso iron, when it becomes nitroso iron, when iron shows +2 oxidation state and it is become neutral. There is a possibility of showing the neutrality of nitrogen monoxide. It acts as a neutral in few cases. When it acts as a neutral, then it becomes +2, and it become plus, with iron become 2, and in that cases nitroso iron. Okay, why I am discussing that part? Because for your JE or competitive exam purpose, this part is very important. There is a possibility of asking the questions on the IUPAC name of the brown ring complexes. Okay, if it is given in like that, penta aqua nitroxide iron 1, it is correct, you should choose this one. Otherwise, suppose it is not given, it is given in your the 4 answer, penta aqua nitroso iron 2 is there, then it is that one also correct. Suppose it is not in your multiple choice, then only that one is correct. Okay, now what is the oxidation state of iron? Here +1 oxidation state. Okay, so these are the very important concept. Let us observe practically how the brown ring is appeared during the brown ring test. Okay, let's move.